Hello students, we are solving the IB Math EA AGL past paper questions and currently we are solving the IB Math EA AGL November 2022 paper 2 past paper. Today we will be solving the question number 11, that is the second last question of this paper. You will be getting the links to all the previously solved questions of this paper and of the other papers in form of playlists in my channel NS Online Math Tutoring Classes. So without any further delay, let us start answering question number 11. The maximum mark is 15. The function f is defined by f of x equal to e to the power of 2x times 3x minus 4, where x belongs to the set of real numbers. Subpart A's question is find f dash x, the first derivative of f of x. So, of course, we will be using the product rule to get the derivative. Okay. So I can start from here. So let me write the f of x expression first of all, equal to e to the power of 2x and 3x minus 4. So therefore f dash x is equal to, first of all I am differentiating this. This when differentiated will be giving us e to the power of 2x, and when we differentiate the power, that is 2x, we will be getting 2. So it is 2 times e to the power of 2x, and this part will be staying, and plus now we will be differentiating this part. The derivative of 3x minus 4 will be equal to 3. So this is 3 and e to the power of 2x. Okay, so I can keep it as it is, or I can write e to the power of 2x. I can take e to the power of 2x common, and this is 2 times 3x is 6x. 2 times negative 4 is negative 8 plus 3. So therefore, f dash x is equal to e to the power of 2x and 6x minus 5. Okay, but you can keep it in this form. This can be your final answer as well. Okay. Fine. So we have answered the subpart A. Coming to subpart B, hence or otherwise, find the coordinates of the point on the graph of y equals f of x where the tangent is parallel to the line y equals x. Y equals x means y equals 1 times x. So the gradient of this line is m equal to 1. Okay. And since the tangent will be parallel to this line, the gradient of the tangent will also be equal to 1. And what is the gradient of the tangent's expression? It is f dash x. So we have to equate this expression to 1. So the tangent will be having a gradient of 1 because it is I'm just writing parallel in this way, parallel to y equals x line. Okay. So therefore the equation of the tangent is this one, not the equation, rather the gradient. Therefore, e to the power of 2x and 6x minus 5 should be equal to 1. Okay? And I have to, of course, get the coordinates of the points, means both the coordinates. First of all, let us get the x coordinate from this expression, then we can go to the y coordinate and find the y coordinate. Okay? So, let me write this as or e to the power of 2x. You can keep this as it is. You can draw the function graph of e to the power of 2x times 6x minus 5. Another horizontal line as y equals 1, and you can get the point of intersection. But I am writing it in this form. Minus 1 equal to 0. So I will be putting this, I will be graphing this expression and I'll be getting the 0. Okay. So add graphs e to the power of 2x. Again, you may write 2x, but I think to be on the safer side, I always put the multiplication sign as well. Okay. So times by 6 times x minus 5 minus 1. Enter. Okay, you see this is the 0. I have to get the x coordinate, x value of the 0. This is 0 0.862 999. 0.862 999. Okay, so therefore x is equal to 0 0.862 999 using GDC graphs. Okay. So what is the corresponding y value that we have to find? The corresponding y value will be, this is the function expression, so we will be substituting, it will be e to the power of, y will be equal to e to the power of 2 times 0 0.862 999. Okay, and 3 times the same thing, 0 0.862 999 minus 4. Okay, so this will be the thing. Fine, so let us get the calculator again, and it is e to the power of 2x. Fine, e to the power of 2 times 0 0.862 999. Okay, 0 0.862 999 times 3x minus 4. 3 times 0 0.862 999. You may take up to 3 significant figures, but I always take more number of digits for the intermediate calculations. Minus 4. So minus 4. Okay. Enter. Negative 7.92719. Negative 7.92719. Okay. equal to negative 7.92719 most probably. Let me check once more. 92719, yeah, 92719. Okay, so therefore the coordinates are 0.863 and this is negative 7.93 up to three significant figures. Okay. Fine. So now we come to this part. The region enclosed by the curve y equals f of x, the x-axis and the y-axis is rotated through 2 pi radians and about the x-axis to form a solid of revolution, and the part C's question is find the volume of this solid. First of all, let us see where is the region lying. Okay, because it is paper 2, we can definitely graph this function. So e to the power of 2x and 3x minus 4. Okay. E to the power of 2x. Okay. Times 3x minus 4. I hope I am correct. E to the power of 2x times 3x minus 4. Okay, yes. Yes, okay, fine. One thing that we can realize is, you see this part, it is just moving parallel, means it is not parallel to the x-axis, but actually it is moving closer and closer to the x-axis. That means the x-axis is the horizontal asymptote. It is not that it is on top of the x-axis. Do not miss, because the window settings is in that way. The graph is appearing to be on top of the x-axis. It is not that way. The graph is trying to be as close as possible to the x-axis, because the x-axis is the horizontal asymptote for this graph. Okay, so the the thing that we have to know is which region are we considering, because we know for getting the volume of revolution we have to do the integrations, and it will be a definite integration. So we have to know the lower and the upper limits of integration. So for that, it is necessary to identify the region. Okay. So if we move towards the left side of the y-axis, you don't actually have any region which is a bounded region, whose volume, which can be just rotated about the x-axis and you get a solid thing, solid 3D object. Because this is not on top of the x-axis, it is just moving closer and closer to the x-axis. It is never meeting the x-axis or crossing the x-axis on the negative side of the x-axis. Okay, so you will not be having any bounded region on this part. And from coming to the positive side of the x-axis, if you just try to take the region above the x-axis, you don't have any bounded region over here, because it is moving up. Like if you just continue to move up your graph, you will be seeing that it is just moving up. Okay, you can do graph trees also. By the way, I have got this minimum point, but I really do not need, I will definitely not be getting the coordinates of the minimum point because I do not need that. Rather, I need the upper and the lower limits of integration. Those are the x values because it will be integrated with respect to x. The region is rotated about the x-axis, so it will be dx. Therefore, we have to get the upper and the lower boundary of x. So therefore, which one is the bounded region? This one. This one is the bounded region. You see, it is going down, coming up. This is the x-axis and this is the y-axis. So this is the region that we are interested in, which will be getting rotated. Okay. So this is the bounded region. You have to first of all identify which region are we taking, should we be taking. Okay. Only then can you get the limits. So since this is the bounded region, you see this part is this whole y-axis is having the x value as 0. The only value of x is that we have to find out is the upper limit of x, that is this 0. Okay. So let us go to analyze graph and 0, and this is this. Okay. So it is 1.333, it is 333 recurring. I don't want to write the upper limit as something recurring. How many threes will I be putting? Rather, I prefer to write the upper limit as a fraction. Okay. So, okay. Now that we have known about the two limits, first of all, let us write that. Okay. So, this will be, what is the volume of revolution formula? It will be equal to pi a to b y square dx. Okay. So, this is the formula. You'll be getting this formula in the formula booklet as well. So, and y is what? Y is this. And we have found the lower limit as 0, but what about the upper limit? So, upper limit is 1.3333. So 1 is 1. So this can be written as 1 plus 0.3333, and you definitely know what is 0.3333. It is 1/3. Okay. So this is equal to 1 plus 1 over 3, which is equal to 4 over 3. Clear? So the upper limit is 4 over 3. So let me just write the expression over here. Pi and 0 to 4 over 3. And y is e to the power of 2x. 3x minus 4 whole square dx. Okay. So this is actually the part C is working. Okay. So now we have to get the value of the v using our calculator. So we go to the calculator. Okay. And we have to go to the, okay, first of all, just a moment. I have to write pi times. So pi times. There will be the integral. Therefore, menu I can go from here also most probably. Calculus, numerical integral. This is 0 and this is 4 over 3. 4, 3 coming to this part. Okay. It is e to the power of 2x so far as I remember. 2 times x. Okay. Times by 3x minus 4. Okay. Three times x minus 4. Bracket closed, square, and dx. Okay. I feel I have entered everything correctly, so let me press enter. 164.8496. 164.8496. Okay. 164.849698 or something. Let me see. 164.849698. Yeah. So, therefore, volume of the solid is equal to 165. I don't know what is the unit, so it is unit cube up to 3 significant figures. Okay. Consider a function g such that g of 0 equal to 1 and the first derivative of g of 0 is equal to, means first derivative of x when x equal to 0 is equal to 2. The subpart D's question, it is having two further subparts. Find the value of first subpart is I is f of g of 0. It is the composite function, so f of g of 0 can be written as f of g of 0. Okay. And what is g of 0? It is equal to 1. It is f of 1, which is equal to f was, let me just show you once more, e to the power of 2x times 3x minus 4. Okay. So it is e to the power of 2x means 2 times 1 times 3x minus 4, 3 times 1 minus 4, which is equal to e to the power of 2, and this is 3 minus 4, which is equal to minus e square. Okay. So this is equal to minus e square. This is a paper 2 question. You can give your answer in some decimal number also, but I think you can give your answer in this format as well. Okay, so let us come to the II part. F of g, that is the first derivative of this composite function. So this will be equal to f dash g of 0 times g dash 0. Okay, that is how we differentiate the composite functions. Okay. So g dash 0 equal to 2 and g of 0 is equal to 1. So this is equal to f dash 1 times g dash 0 equal to 2. Okay. And what is the expression for f dash? You can see the expression for f dash is this. The expression for f dash is this. E to the power of 2x times 6x minus 5. Okay. E to the power of 2x times 6x minus 5. So it is e to the power of 2 times 1 times 6 times 1 minus 5 times 2, which is equal to 6 times 1 is 6, 6 minus 5 is 1. So this will be equal to minus, or not minus, it will be 2 times e square. 6 times 1 is 6 minus 1 is 1. 1 times 2 is 2. So it will be 2e square. Okay. Again, you can give the answer in decimals. So this brings us to the end of this question, answering of this question number 11. Thank you for staying with me till the end. I am Nilanjana Sanyal. I am an online IB Math ESL and HL level tutor. I tutor students from both within India and outside India, and I offer both one-on-one and small group online tutoring services to my students. And as you are seeing, I am solving the IB Math AHL past paper questions and uploading them in my YouTube channel. In case you are liking my explanation, please to give this video a like and please to share this video with your friends so that even they can get benefited by watching this video. And in case you are having any questions, any doubts, please feel free to write to me in the comment section. I'll be happy to help you. I'll be happy to answer your questions. And we meet again very soon in our next session. We will be solving the last question of this paper, that is question number 12. Till then, bye.